welcome back. I hope you had a nice, good cloud computing day yesterday. I hope now you know what cloud computing is about. Today I'll mention it a bit on how it ties to smart infrastructure, but that's about it for cloud computing. If you have any questions, feel free to ask me later on today. Okay, so today we're going to be covering smart infrastructure. We're going to start smart infrastructure, highlight what it's about, and then we're going to go into a particular example, which is smart grids. An important part of smart infrastructure is smart grids, power grids. There's a small video similar to yesterday where it explains everything, and you need to be careful while watching it. Take notes, because later on there are activities where you need to know what was in the video. Let's see. In the afternoon, we have a guest coming. Before he comes, he's a PhD candidate, first-year PhD candidate in the EC department at U of T. Before he comes, you have an activity when you're going to prepare a presentation, a PowerPoint presentation, and you're going to present to him related to smart grids. It's going to be a short one, around 10 minutes. And then after that, he's going to present his view of things, describe what has been done in smart grids from the communications aspect especially. He will talk about game theory and how game theory has been used or can be used in smart grids. Okay, any questions to start with? Yes?
The PowerPoint, will we do it in groups or individually?
In groups. In groups. Okay, so smart infrastructure. What is a smart infrastructure? Nowadays we hear smartphones, smart devices, smart fridge, smart home, smart house, smart anything, right? It's being used a lot, but we don't actually understand what it is. You're hopefully going to become engineers, so you should know that what it is from now. Let's see. When you hear smart infrastructure, what do you think? What do you need for this? Yes? Efficient. Okay, it's trying to achieve something, right? Yeah. It's trying to give you an optimal solution for something. You have an existing system, you're trying to make that solution better. Okay, if you want to do something efficient, what do you need to get first? Sorry? Data. You need data. Why do you need data?
How do you know if something's better?
You need to know how things are working exactly, right? More data might mean you get better information, and using that information in a good way will help you do things in a better way. Okay, you have the data, and you have a system somewhere, and you can imagine data from different sources. What do you need in between? How do you get that data into your decision maker? Communication, right? So you need to gather up data with sensors, some kind of sensors, send that data with communication mechanisms. It could be wired, it could be wireless, depending on where you are. And then there's a decision going to be made. After this decision is made, you need to send that back to whatever controller has to change the environment. So let's see, you have a few examples in a bit. One possible definition, I think I've made this up, is infrastructure that can adjust to changes that are happening in the environment so that it will give you good performance. It will give you improved performance. Or a better word is optimized performance. So the best performance whenever these changes are happening. So what is required for this? Data, and you get this from sensors. data to flow back from sensors to a system, which means you need a communication system. You need a central system which has good enough view of your whole network, whether it's a power network, whether it's a communications network, whether it's transportation network, whatever it is. It has to be knowledgeable enough in terms of your overall network in order to make an optimized decision, right? And you need to be able to send back the decision, the optimized decision, to a controller that can change things in the actual environment, and the controller needs to perform this action. Okay, let's jump to a couple of examples. You have a traffic light. Okay, you have a traffic light with actuators. Actuators are the simplest example is the push button for pedestrians. Okay, has anyone used that? I'm guessing you've seen that. Who has seen a push button on intersection? Okay, so push buttons are used for pedestrians on local roads, and usually you have a major road and a more minor road, and the major road has a longer green time, while people who are on the minor road will have to wait more because there's not enough vehicles that actually use that road a lot. Whenever pedestrians are crossing across the major road, so you have the major road and people are trying to cross it, major road has to stop, right? They have to have a red light. For the red light to appear, you either have to have your cycle ending, or you can use the pedestrian push button, right? So in order for that pedestrian push button to make a change on the traffic light, okay, what do you need? Let's think back in terms of the few things that I mentioned on the previous slide. What do you need to get? What do you need to do? What's the first thing you need? What data do you need? Yes?
How often do cars pass by the intersection?
First of all, you need that the data of how often vehicles pass. That's the flows on your system. Based on that, you would have a pre-designed intersection. Now, you have that set up, but in addition to that, you have the ability to change based on people crossing by. So they're going to push on they're going to use a push button for crossing. What do you need to do with that? What's happening there exactly? Yes?
Push button is a sensor.
So you need a sensor. So that push button has a sensor. It detects that someone has pressed it. Next, what are you supposed to do?
Sends information to the traffic light.
Okay. So you have different places where someone could press, right? It could be, if the major road is north-south, the person crossing could be heading east or heading west, right? So you need to detect both of those with sensors. Sensors, so the first one is what you are saying, measuring the flow of the vehicles and monitoring pedestrian crossing buttons. Sensors have to send this to a central system. It's usually wired, but you can also have it wireless. Did you go down and get the sheet? You have to go to GB 173 and get a sheet. Okay, then what will the central system do with this? Based on the data that you're getting, what is it supposed to do? It's supposed to decide whether to change the situation that it has. So the current situation is there's 20 more seconds for the green light. But if someone is pressing on the other side that they need to cross, it's supposed to decide that whether they're going to stop, whether it's going to stop the vehicles from going through so that the pedestrians can cross, especially because they've been waiting there for some time. Okay. So it will optimize the data that is coming from here. Another thing that it will use the data that's coming from here, and it will also use the vehicles that are coming. An interesting thing that I didn't know a few years ago, and I now test it when I'm on a local road, is before the intersection, depending on how wide the intersection is, it could be something like 10 feet to maybe 15, 20 feet, depending on, again, how big it is. You have a detector there. So imagine the vehicle's going north. It's really busy. Or you have many vehicles going. And just before that, just before they arrive to the intersection, you have that sensor. Now, there's someone trying to go west. They keep on pressing. If they press, and during that same time, on the sensor, there's still a vehicle coming, the green light won't change. Why? What's the most important element in the system? It's how busy the vehicles are going north. So in addition to taking data from sensors that pedestrians are pressing, it also sees, well, are there still vehicles that I need to clear out, right? So if there are any other vehicles passing through that sensor, which is around here, let's say, then it will go through. And I've tested this. I've tested it. So you do it when you're doing it when the vehicle is crossing, it doesn't change. When you do it when the vehicle is ahead of that sensor or behind it, it will change. It will change immediately. You press the light, and it will immediately, instead of the green, instead of the red for the pedestrian, you'll see a countdown. Instead of the red light for the vehicle, you'll see a yellow light, and then it's a few seconds of yellow light or amber light, and then you'll be able to go through. Okay. And then the central system needs to send this to each controller, because this has to be working to all 4 traffic lights, right? If the one traffic light is giving a red, the other one has to be green, or else if you put 2 greens, vehicles are going to crash. You're going to have a collision. And this will update the cycles. This needs to update the cycles in order to optimize performance. And on Friday, you have an activity on this. So you're going to be able to see this on Paramix, on the traffic simulator. You will actually see the exact cycles, and you can change them. You can play around with the lights, cause collisions. I tested it yesterday. It's nice. And then based on what is changing, based on how the demands are changing, you can change your lights in order to clear up the road. Okay, so you're going to have a chance to do this on Friday. But the important parts is the elements of smart infrastructure here. Okay, here's another one, advanced parking indicator. So I saw this a few weeks ago in Montreal. What this is telling you, before heading to 3 different destinations, Centre Commerce Mondial, Palais des Congrès, and the View Montréal. So these 3 different places, these are areas. You're not close to these, but it's telling you how many street parking locations you have there exactly before you head there. So that if you're looking for a parking spot, if one of these is really low, if that's like 5, you would say, why would I take a chance, go there, and then I won't be able to park, right? You go through one of the other areas and then walk from there. So this is I would call it an advanced parking indicator. What does this include? What are the smart infrastructure elements to have this work? Yes? Sensors. What type of sensors?
Probably car sensors underneath parking spots.
Car sensors. So you need a sensor on every street parking car spot to know whether there's a vehicle or not. Okay? It's yes or no. What are you supposed to do? Okay, let's see. Okay, so sensors need to send that, again, to a central system. Central system will display the total parking spots remaining in that area. And based on that, who would react to this information? Users will react to this information because they will go to different destinations in case they can find a better parking spot in a different area, and in case there aren't many spots in the place that they originally intended to go to. Okay, so drivers will change their routes to increase the chances of finding parking spots. Okay, so now let's look at what has been one of the driving forces for smart infrastructure. If you look at the past 10, 20 years, a very important element for pushing smart infrastructure is ICT, or information and communication technology. So computing and communication. Things have gone faster, so we're now talking about data, communication, and then processing of that information and doing something with it. This is included in computing and communication. So we started with these. I don't know if any of you are remember some of the bigger cell phones. They look. I had a friend calling. I had a friend in grade 9. A teacher came in with one of those phones, the big ones, and my friend told him, "What is this? Are you carrying a fridge with you?" It was that big, but those days are gone now. Okay, so things have gone forward, and you have data centers that look like this now, huge computing resources. The server room that you saw yesterday is pretty old compared to stuff like this, with supercomputers. Another element is Moore's law and economies of scale. Moore's law is a concept in computer hardware. I won't explain it here. Let me see. So now everyone has PCs. At the beginning, it was you needed it for particular work. Now everyone has it. Everyone has different types of software, and they have all become commodities. So bandwidth also. Now you have Ethernet in data centers between different servers, and you have new computing models, and you have virtualization. So we're already using cloud computing elements in our work, in our everyday life, you could say. Okay, so just a recap on cloud computing. So what are the benefits? Pay as you go. You don't have a big upfront cost at the beginning, and you can do resource management. You have a ratio of 5 or 7 times reduction in cost. You can dynamically move virtual machines to different places, and you have lots of other benefits. Especially towards the end, it's helping energy profitability throughout your system. Another aspect is communication. So things that are connected in various different places, right? So now you have sensors, different types of sensors, environmental sensors. You have commercial sensors, such as the ones we mentioned, and you have industry equipment sensors. So you could think of an ATM machine as a sensor. If someone enters a wrong password, that gets transferred. There's an alert for it that gets transferred to a central system. If that is happening in 10 different places at the same time, that card is going to be locked, right? If you don't transfer that information, then within half an hour or something, they can break that key and maybe get it. Maybe be able to get money out of the account. So you have different people, different sensors trying to communicate, and you need to make sure that the system in the middle can get all this information and route it to whoever wants it. This is a system developed in the computer group in the EC department at U of T. Okay, so smart infrastructure. What are different elements that play into this, or what are different types? You have, let's see. Cloud computing helps provide the monitoring, right? So cloud computing is helping monitor your different systems and scale up and down wherever you need to, and it helps enable smart infrastructure. Now, another element is smart power grids. So we're going to be discussing that shortly. There's green computing. There's network vehicles. So the vehicles now are also getting smarter. You have new devices that you can put in, and they measure your fuel consumption and energy emissions, and based on that you can adjust your driving pattern in order to actually consume less fuel. So, for example, if you drive around 120 as opposed to 140, you'll be consuming less fuel. That's, for example, for truckers. It's used today. Another aspect is, of course, communication. So having all this data transferred in order to make optimized decisions. And I'm highlighting this again. Cloud computing is one of the elements that is a very strong enabler for smart infrastructures. Okay, so why now? Why is it that all of a sudden we're talking about smart infrastructures? One of the big problems that we're trying to solve is carbon emissions. So all of these computing and computing and communications technologies, so ICT, is leading to huge emissions. They are part of our everyday life, but at the same time, they are a big chunk of what we spend, what we release as carbon emissions. And let's see, if a good application in these sectors can reduce global emissions by 15% in 2020. So if you look here, in 2002 up to 2020, you have the power, you have the carbon emissions, and you have, for each one of them, you have one part. This last one is for the PCs, okay? PCs, peripherals, and printers. That's the percentage of how much carbon emissions they have. Then you can also see the data centers and telecoms infrastructure and devices. And you can see that these devices over time, because now every single home has them, every single home has multiple of these devices, they are leading to lots of carbon emissions. And we need to do things better in order not to cause this. That's why we talk about green cloud computing. That's why we're talking about putting things in the North Pole in order to cool things cheaper. Green microgrid computing, which is in power grids. We're going to mention it this afternoon, actually in a bit. Green networking. And, okay. Again, some of the things that we have started talking about is teleworking. So some people are working from home now. Why? They have the, what means do they have to work from home? Equipment, other than the equipment. So networking, right? If you don't have networking, you can't work from home because no one can actually see that you're working. So video conferencing, you don't have to fly and spend fuel or drive in order to go to a meeting. You can have video conferences. Transport optimization, smart motors and industrial processes. So all of these things are ways in which we're trying to reduce the emissions with smarter infrastructure. So what are the issues that we have here? So we're trying to adjust the supply and the demand together. As we saw yesterday with cloud computing, that's one of the mechanisms, and you see it now with power grids. You're also trying to estimate the supply demand from a network of sensors. In order to be able to know what the demand is, you need sensors. There's no way around it. If you don't know what to expect, then you have to have so much supply and you're wasting, right? So demand driven by aggregate behavior of community of users. Another element here is how people's behavior and the community of users' behavior together affects what's actually happening in the society. So in the afternoon, we'll be working on this, and we'll see how game theory can actually be used here. Performance and reliability requirements and impacts. One of the ways one of the important things is measuring, monitoring, and getting good performance results. Based on that, we can readjust our systems. So environmental impacts. So the research challenges have to do with, basically, you start thinking from an engineer's perspective, you start thinking what are the wireless networks that you need, what data gathering, filtering, mining, and event handling techniques do you need. So all this data that you're getting, how do you deal with it? Do I use all of the data? Do I filter it first? What if one of the sensors is giving me false information? Let me give you a small example here. For detecting fires, a cheap way of doing it before the fire happens or spreads is dumping a set of wireless sensor nodes. They use up solar energy. The material that they have is, what's the term, biodegradable or recyclable. And they will communicate with you when something happens. So when they detect that there's an increase in the heat around them, they'll be sending you information. Now, what are you going to do when you have multiple of these? What you can do is you have to filter out some of the information because a sensor might malfunction, right? If one sensor tells you there's a fire and 10 other sensors tell you that there isn't a fire, you know there isn't a fire, right? That's where yes, data gathering, filtering, mining, event handling, all of these are very important to filter the data that you're getting in. Another element is if you think of people driving and you have data coming from vehicles, you're trying to figure out whether there is congestion. If you have two people who have stopped on the side of the road and they're getting coffee from Tim Hortons, for example, then that doesn't mean there is congestion, right? You need to ensure that you get enough data and filter out the anomalies, and that's a science by itself, in order to figure out what's exactly happening based on the data. Important element here is, because things are dependent on the community of users, what are the incentives that you provide for users in order to behave in a way that is beneficial for the environment? So one important element here is, if they act selfishly, then they're going to suffer, then everyone is going to suffer. So we're going to cover this today in the afternoon and tomorrow. And here you also have SLAs and policy-driven management systems. So having ensuring certain performance levels based on what the client wants, and also security and reliability, of course. Now, do you have any questions about smart infrastructure and what the elements are of smart infrastructure? Okay, let's ask someone. What are the elements of smart infrastructure? What do you need first? Sensors. Next, what do you need? Data is going to be gathered from sensors. What are you going to do with it? You need to analyze it. So you need to, first of all, send it somewhere, usually a centralized controller, a centralized system. You need to analyze it. So first you're going to filter out the false information. You're going to aggregate it because you don't want to keep the whole big chunk of data. And then based on that, what are you going to do? You're going to come up with a decision, right? You're going to come up with a decision. Do I leave things as is, or do I change things to have a better performance? And then I send that back to whoever needs that information. So that could be several different traffic lights. That could be a sign that you're seeing on the road. That could be, if you think of cloud computing, scaling up or scaling down, getting an extra virtual machines. So all of those things. Okay? So the next time someone tells you smart something, if they don't know what they're talking about, ask them. Okay? Part of being an engineer is being critical. You have to ask the right questions, and abusing the word of smart in marketing is something that I don't really appreciate, especially if people don't know what they're talking about. So now you know what smart infrastructure what is the smart part of smart infrastructure, and in the next few years, hopefully you'll be contributing and making things smarter as aspiring engineers. Okay, so are there any questions about smart infrastructure? Now you saw a 10-minute video of smart grids. You're going to work together in groups of 3 or 4, so the same groups that we had yesterday. You're going to highlight what are the problems, the exact problems that smart grids are trying to solve. How are they trying to solve them? What are different ways they're trying to solve them? And the biggest thing is what components are needed. So what are the different components that you need in smart grids? Try to imagine them. Try to think of them from a smart infrastructure perspective. Be as detailed as you can. You have 40 minutes for this. Okay? So you're going to come up with everything you need to know with smart grids, and then we're going to discuss it like yesterday and go through the details of what you have in smart grids. Okay? Any questions before you start? So if you just think about, for example, the last part, that should take you at least 20 minutes. The different components that you have. If you need to draw a system, how it needs to be, starting from the sensors to the controllers to where things need to go, do it. I'll be going around and asking questions to you to make you think a bit more. And then we're going to go back and discuss what you came up with and discuss officially the elements of smart grids. Okay? You can start.